Good morning, students. This session we are just going to see about the morphological operators which is developed for image processing. Morphology is nothing but set theory concepts from mathematical background. It is used as a structural descriptors in image. It is used in feature detection, image segmentation, image enhancement, and also for sharpening like enhancement, etc. This mathematical morphology is used in image processing by defining a matrix or small image called structuring element. We'll also call this as a template. This structuring element is positioned in your original image. According to the structuring element property, it will extract the original image features or it will just change the original image. So we will just position the structuring element in original image. The structuring elements and the original image pixels behind the structuring element will be compared. So the neighborhoods and the structural elements are matched. Based on this, we are defining the morphological operators. These structuring elements, we have to consider two things. One is the shape of the structuring element. Another one is the size of the structuring element. The shape is used to define the structure, and the size is to define the similar structure with varying size. So there are n number of structuring elements we can define. So here this particular structuring element is a square structuring element. You can see a 3x3 structuring element. So here the structuring element is a diamond shaped structuring element. It is the structure of this structuring element is or shape of the structuring element is preserved by defining the values of the particular area by ones. And here you can see the another one structuring element. It is also a diamond shaped structuring element, but the size of the structuring element is very large. There are many types of structuring elements available: disc shaped, square shaped, octagon shaped, diamond shaped, linear shaped, and rectangular shaped structuring elements. Disc shaped structuring element. So this structuring elements we can define it in our any implement as an implementation in MATLAB, in Python with OpenCV, in NV software. All the image processing software support for these operations. So for defining this structuring element in MATLAB, we have a direct command strel, that is structuring element of within the argument we have to pass whether it is a disc shape or square shaped or octagon shaped or diamond shaped. So why these different types of shapes are used? Because in an image there are more number of shapes available. So that is why any one of the object or background or the target will match with this shapes of the structuring element. So here you can see the structuring element is a disc shape. So the disc portion covered by 1 and the remaining portions are covered by 0. So we can see the disc shape in the structuring element itself. Similarly here we can see the square shape, and here we can see the diamond shape. The diamond area only covered by 1s, the remaining area are covered by 0s. So here the command also we can pass diamond as argument. Similarly for rectangular structuring element, octagon structuring element, all can be defined. Now the main idea of morphological operators is defined by the 4 operations: dilation, erosion, opening and closing. Among these 4, this primary operations are dilation and erosion. We will see this dilation and erosion in this session, and we extend this with opening and closing. Dilation is nothing but enlarging or growing the foreground pixels and shrinking the background pixels. So this particular operation will enlarge the, so you can see here this is the input image, binary image. Now we are seeing the binary morphological operators which is performed on binary images. It here the object or the foreground pixels are enlarged, so more whites included, and the background is shrink, that is zeros are eliminated. So how this is how this we can do. The value of the output pixel is maximum value of all the pixels in the input pixels neighborhood. That is, this is done by just moving the structuring element in an image. So here consider it is a 3x3 structuring element. In this particular rounded value is nothing but the seed point or origin. We have to fix this structuring element in the original image. Suppose if you want to change this particular position, you have to fix the seed point here, and you have to compare the entire neighbors, that is the structuring elements, with the neighbors, 8 neighbors. So here at least one element in the structuring element matches with the neighbors of the original pixel, then we can change the original pixel value as 1. Otherwise it should be 0. Okay, no pixel is matched, then it will be 0. At least one element is matched, then it will be 1. This is called dilation. So dilation, the name itself, it dilutes the image, or it just duplicates the values of ones. So here you can see the operations, dilation operation. When we perform it on an image, what will happen? So here this is a square object. If you apply dilation, here 2 times dilation is applied to produce this output. So the foreground gets enlarged, and also the background gets more reduced or shrink. You can also see the corners have been smoothed, and this boundaries we can preserve this. That is, convex boundaries will become rounded and the concave boundaries will be preserved as they are. Okay. So here, this dilation also used to remove noises. So in the case of the first image contains so many salt and pepper knives, specifically pepper knives, black spots. So the dilation operation which match with the structuring element, at least one pixel is matched with the structuring element's neighbors, then that pixel will be we can make it as 1. So most of the black pixels are turned to 1. That is why in the output image we couldn't see any black pixels or pepper knives. So this can be used as a enhancement technique, and also dilation is used to extract the edges by just subtracting the original image. So here this is the input image. After dilation, the original image and dilated image gets subtracted to get the clear edges of that image. The second primary operation is erosion, that is counterpart of your dilation. So here erosion, it enlarges or grows the background pixels and shrinks the foreground. So you can see it is only border area. We can extract all the intermediate portions. We make it as background. Okay. So it is volta operation of erosion. So here the structure says structuring element is matched with the original image. Here the operation is, if all the pixels in the structuring element is matched with the all neighbors of the particular image region, then only we have to make this as 1. Otherwise it is said to be 0. If anyone does not match, then you have to turn this off. That is 0. So most of the time all the pixels in the structuring element matrix and the original matrix will not get matched. So most of the time it will make it as background pixel, that is 0. So this is the effect of erosion in an image. What do you understand from this image? So you just use the definition of erosion, that is, it enlarges the background and shrinks the foreground. And how this is we can do. So now you answer for this question. This is the input grayscale image, this is the binary image, this is the output after erosion. What is happening here? You just okay, this particular operation just shrinks the foreground, so and enlarges the background. So backgrounds enlarge, so wherever the object get touched, those portions the background enlarged, so black portions are increased and the white portions are reduced. Automatically we could able to segment the white and black regions clearly. It is used to distinguish the black and white portions present in the image. So we can effectively use this erosion and dilation to define the structures in an image. So the next operation is opening. It is derived from the fundamental erosion and dilation. So opening is nothing but erosion followed by a dilation using the same structuring element for both operations. So we can use disc or we can use square, but for both erosion and for both dilation we have to use this. First, so the image get eroded followed by a dilation. So what will happen, or what is happening here? So you can see the best example of opening. So it here it consists of mixed of objects, circle and line objects. So here they have used the disc-shaped structuring element. So the disc portions get opened, the remaining portions get closed. So automatically we can separate the circular objects clearly by opening. Similarly, closing is the counterpart of opening. So here dilation followed by erosion. So it closes the regions and almost all the small component get closed, and we can get a regular shape of the object. Here also, by closing small parts, we are able to clearly distinguish the object, the foreground and background object. So these are the applications of morphological operators. This we can extend this erosion, dilation, opening and closing further and further to define so many applications. Thank you.